So today we would be seeing computer vision. So what is computer vision? And we would be implementing a basic model using TensorFlow in computer vision. So basically computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos and posts. And basically you can think it like that. When you are young, you are a small baby. At that time, how do you recognize what objects do you see in real life? Basically you can understand it like that. Your parents put a label on them, that okay, this is table, this is a laptop, this is a bed, this is a door, and from that you learn. They tell you, but we definitely can't tell the computer by just speaking. We need to tell it by typing something, by giving it some labels. So that is what we are going to do here. We are going to give some labels to computer, that okay, computer, see this object is this, and this is how we would be defining the labels and classes. And then computer would be learning from it. The model would be learning, okay, that this is the X object, this is Y object. So if AI enable computers to think, computer vision enables them to see, observe and understand. Yeah, so artificial intelligence enables computer to think that how one step can be taken and how to move the next step. Computer vision enables them to see, observe and understand. So now starting up with the TensorFlow part, obviously we would be going to runtime, we would be seeing its GPU and we would be saving it. I would recommend you to use GPU because yeah, it's free, first of all free of cost, and it's so fast that you can train models in just few seconds. So I would be doing like that, TensorFlow, and it's 2.5, just make sure. So the data set that we are going to look in this example is a Faishon MNIST data set. So Faishon MNIST data set is a data set of Zalando's article images consisting of a training set of 60,000 examples and a test set of 10,000 examples. Each example is a 28 by 28 grayscale image associated with a label from 10 classes. So yeah, you can see here these are the types of images that are available in the given data set. You can see t-shirt, top, trouser, pullover, dress, coat. If you want to see an example, I would just show you the data set. Yeah, if you go here, you can see these type of data sets are available in the Faishon MNIST. And this is how you would be telling the model that okay, this is t-shirt, this is trouser. You are giving it label and telling okay, the computer, this is a t-shirt, this is a shoe, and computer would learn from it. Okay, now so the Faishon MNIST dataset is available directly in the tf.keras database API. We just need to load it like this. Keras has a lot of datasets. If you want to explore them, just put this in the browser and you would be getting all the datasets that are available in Keras. They are not just one, but there are a lot of datasets like house, Faishon MNIST, the IMDb classification dataset, MNIST, and a lot of datasets. Even TensorFlow datasets consist of it. So I have imported the MNIST dataset from there. And now what I would be doing is we would be calling a load data function. So what basically this function does is it would be splitting your data into two data: training images, training labels, test images, test labels. Now you must be thinking that why I am doing this. I would just explain you that in a later stage. For now, just remember that we are using that load data function to put the data, split the data in two stages, that is training images, training labels, and another set that is test images, test labels. So we would be running like that. Yeah, now coming to the next part, that is what does these values look like. Let's print a training image and a training label to see. So for now I would be printing the first image, that's the second image that is present here. So it's a shirt image, you can see. So it has created an array of shirt like that, and it's a shirt, you can clearly see. Now just let's do experiment with it. I would put it here 0, and let's see what's this. I guess it's a boot. I remember, yeah, it's a boot. You can see here uh, it's an array created, multi-dimensional array created of boot. Yeah, so I would like to experiment with 2. You can experiment with it as many times as you want, and I would run it here. So what is this? Okay, okay, I guess this is a bag, I guess. Yeah, I'm not good at judging these things. I guess that's a bag. Yeah. So yeah, you can experiment with the data set like that. You can see how images are visible. So what you would notice here is all the values are between 0 and 255. So if we are training a neural network for various reasons, it's easier if we treat all the values between 1 and 0. This process is known as normalization, and fortunately in Python we have got a function for that. You just need to do training images slash 255 test images equals to test images slash 255.0. So it's good to keep all the values between 0 and 1 for making it for not having any variation between the images, because you can think it like that there may be some image that has got different dimensional values, another image be different, so it makes the work for computer a bit hard. Yeah, so I would be doing it like that. So as I told you, now I would be telling you why we have got two data sets. The reason is we have got the first data set, that is training data set, the second data set as test data set. So training data set would basically be used to train the model. We would be telling that okay, let's see, I am giving you such data, just see and observe and learn that okay, this is a boot, this is a shirt, this is a pant, this is a bag, socks, and model would learn from it. And then we would be using some test data which the model hasn't seen yet. You can imagine it like that. I would be showing the model three red shirts, okay, three different color shirt, that is red, green and blue. And then I would be asking the model, this is part of training data, and then I would be asking the model that okay, please tell me what is this, and I would be showing it a different color shirt, let's say a pink shirt. Now that would be a test data, and I would be seeing okay, is the model efficient enough to tell me that okay, that is a shirt. So I would be running that here. Yeah, so from here you must have got an idea that what we are going to do here in the next step. I have just ran it, and so basically in the last video I told you this is the part where we are defining the model, that what things it is going to take in it. So I would be defining it once again. So here you can see tf keras.models.sequential. So sequential is that defines a sequence of layers in the neural networks, that what are the layers that are going to be in the neural network, one above another, like that. And here you can see tf.keras.flatten. So remember when we remember where our images were a square, when you printed them out, flatten just takes that square and turns it into one dimensional set. You can imagine the shirt image was just a square image. Now at that time we would be needing something to normalize the image and turn it into a one dimensional image, and flatten would be doing that. So what Dense does, it adds a layer of neuron, simple, and each neuron has got an activation function. I am using an activation function here as ReLU. You can even use something else. You just go to the tf.tensorflow activation functions and you would find a bunch of functions there. I'm just using ReLU for now. And in the second layer, I would be adding 10 and another activation function, that is softmax. As I told you, there are a number of functions, so there is no limit. You can experiment with anyone and as much as you want. So each layer of neuron needs an activation function to tell them what to do. There's a lots of options, but for now we would be using these. So ReLU efficiently means if x is greater than 0, then we would be returning x, else we would return 0. So what it does, it passes only one values greater than 0 or to the next layer. And what softmax does, the function here, uh, it takes a sets of values and efficiently picks the biggest one. So for example, if the output of the last layer looks like 0.1, 0.1, 0.5, it looks like something like this. Yeah, you can see here, I've also written it here. It saves you from fishing through it by looking at the biggest values. It would be looking turning into this. The goal is to save a lot of coding. Okay, I have written another function here. I have used 510 here, 10 here. You means it's totally up to you how much neurons you want, which activation function you want to use. It's totally your choice. So now we would be compiling the model. So for compiling the model, you do this by compiling it with an optimizer and a loss function, as I told you before in the last video. And then you would be calling model.fit. You can even call it history equals to model.fit. It's totally your choice. I would prefer tell you to choose model.fit directly. So in future, if you data looks something like training data, then it might make a prediction of what the data would look like. So I would be compiling the models. I have given it as 5 epochs, and this is an optimizer function, this is a loss function, this is a metrics function. So as I told you, even loss and optimizer are present in a number of quantities. You can choose any one of them. For now I have choose partial categorical cross entropy because there are because there are a number of data sets. I can even use binary cross entropy here, but that is used for a single two data sets. For example, I am differentiating between cats and dogs. At that time I would be using binary cross entropy, but now I have got around 9 labels, so I am using cross entropy. You can just go on to the Keras API website and you will find a number of articles and loss functions there. And then I would finally be doing model.fit training images, labels and epochs equals to 5. You can even put it as 10, 15, as much as you want. So yeah, I would be doing like this. If you would have used TPU, it would have taken a lot more time, I guess. For now it's using GPU. As you can see, it's pretty fast. The accuracy was 82%, then increased to 86, now 87.7, 88.62, and then 89.5. Yeah, so we have got an accuracy of 89%. That's, I guess, a very nice accuracy based on we have given it only 5 epochs. If you would increase the number, the accuracy would obviously get increased. Okay, now after we are done training, the value should look like something like 90%. Mine is looking 89% because last time it did it in 90, so I have written 90 here. It totally depends on the user, how many times it is training, and depending on every time you train the model, it would give you different accuracy. So you can try it with different loss functions and you can increase the epochs. Okay, the spelling is wrong. The results would be different. Now coming to the last part, but how would it see work on unseen data? Now imagine, as I gave you the shirt example, how would it perform on that? There is a 50 chance that it would give, it's another thing, it's a 50 chance it would get shirt. So let's test on it. We would be evaluating this function dot evaluate is used to tell that how our data is performing on the new data, the data we are giving it now. Okay, I am giving it, yeah, it's giving 87% accuracy. I guess it's pretty nice because we trained it only on 5 epochs. The model will return different results for every user and totally depends on the training process of the model. It can even give you 99% accuracy and even 80% accuracy depending on what functions you have trained it on. If you have given it more epochs, a more better function, the more better data, it would give you more accuracy and the graph would go up. But for now it's 87% is pretty nice for the time we have given it the data. So you must have got an idea. Just revisiting all, we imported TensorFlow, we split the data between two sets, training and test. Then we looked at some examples of the data. Then we normalized the images by dividing it by 255, and then we defined the model, that how the model layers and all is going to function. Then we trained the data here, and then finally we evaluated. So these are the steps. If preparing the data, then making the data, normalizing the data, then preparing the model, then training the data model, and then evaluating the model based on the test data. So this is how the whole computer vision works in a very simple way. If I have given a very brief overview, it can be a bit more complicated, actually a lot more complicated. So this was just a beginner friendly tutorial on computer vision. Hope you have enjoyed it. I would be explaining more concepts in computer vision. It's just a very small model, a very basic model made on this, but things can be quite complicated and more accurate. So I would be telling that in future videos. So thank you and have a nice day.